Okay, so for example here, we're going to integrate from 2 square root of 3 over 3 to 2. Integrate 4 over t times the square root of 49t squared minus 49 with respect to t. Okay, so this one once again looks like the integral of du over u times the square root of u squared minus a squared, which equals 1 over a times secant inverse of u over a plus c. Even though those two u's aren't equal, still is in the same ballpark, because we can always make them equal. Okay, so once again, first thing you want to do is just factor out that numerator and bring that dt up top. So we're going to factor out the 4. Okay, so that's the integral from 2 square root of 3 over 3 to 2. Bring that 4 out to the front, so that's dt over t times square root of 49t squared minus 49. Yep, move that up a little bit. Which brings us to our second step, which is the rewrite. Okay, so our 49t squared is just 7t squared, and our 49 is just 7 squared. Okay, so that gives us 4 times the integral from 2 square root of 3 over 3. Uh-oh, why did I write 2 there? That should be 3, and that should be 3. Of dt over t times the square root of 7t squared minus 7 squared. Okay, so this u is equal to 7t, but that one isn't. So really all you have to do is multiply it by 7 over 7, and it'll match right up. Multiply by 7 over 7. And that will give us 4 times the integral from 2 square root of 3 over 3, 7 dt over 7t times the square root of 7t squared minus 7 squared. So even if it's missing, we can still maneuver it to equal whatever we need it to equal. Now we have our u's equal. So we have u here and u there. So u is equal to 7t, and a is equal to 7. Now this 7 dt, I'm going to leave the 7 up here instead of bringing it out front, and you'll kind of see why. Okay, so we know our a is equal to 7. Our u is equal to 7t. So our du is going to equal 7 dt. That's why I just went ahead and left it there, because we can just replace that whole thing with du.
So you want, because of that,
Mm-hmm.
you're going to replace the whole thing because of the top.
Yep.
So we don't have to take out the 7 to.
Nope.
As long as it equals what the numerator says.
Exactly.
Okay.
Yep, so that 70t is automatically going to be our du. So we just replace that whole thing with du. All right, so which brings us to our third step, replace and integrate. Okay, so that gives us 4 times the integral from 2 square root of 3 to 2, 2 square root of 3 over 3 to 2. Our 70t is our du over u times the square root of u squared minus a squared. And that's going to give us 4 times 1 over a times secant inverse of u over a. And we don't need the plus c because we're going for a definite integral. Okay, so once we replace our a's and our u's, that's 4 times 1 over a, so that's 1 over 7. Secant inverse of u over a, so that would be 7t over 7. Oh, a little too close. That would be from 2 square root of 3 over 3 to 2. Why did I put 2 there? Should be 3. Should I do that? Yep. Did it right the last time. Okay, so we can bring that 1 over 7 out. Actually, I'll bring that right on over to the beginning so we can go ahead and just solve it. So we have 4 over 7, secant inverse of t from 2 square root of 3 over 3 to 2, which is just 4 over 7. Plug in our 2, secant inverse of 2 minus secant inverse of 2 square root of 3 over 3. Okay, and that's going to equal 4 over 7 times pi over 3 minus pi over 6. Because remember, secant is just the reciprocal of cosine. So cosine would equal the reciprocal of 2, which is 1/2. So cosine of 1/2 is true when theta is equal to pi over 3. And same thing for square root of 3 over 2. The reciprocal of that one is just pi over 6. Oh, bring it up a little bit. All right. So once we make that, multiply this by 2 over 2, we get 2 pi over 6 minus pi over 6, which is pi over 6. Oh, make sure. So we have 4 over 7 times pi over 6. This simplifies. 2 goes into 4 twice, 2 goes into 6 3 times. So that's just 2 pi over 21. Bring that up a little bit. All right. So any questions on that one?
Yeah, can you show us how you get the reciprocal from of those, like on the inner circle wise?
Oh yeah, no problem. So let me bring this up a little bit.
I was like, last class, I'm not really remember it that much.
Yep, so we know that secant of theta is just the reciprocal of cosine of theta. So if we have secant inverse of 2, let's say secant inverse of 2, if we let that equal t, then if we apply secant to both sides, the secant and secant inverse cancels out. So we have 2 equals secant of t, or t equals secant of 2. So if t is equal to secant of 2, well, secant of t is equal to 2, then that means that the reciprocal of secant, which is cosine of t, will be equal to the reciprocal of 2, which is 1/2. So this is true when t is equal to pi over 3. So that's when that one came through. Oh, move this up a little bit more. Okay, so we do the same thing for secant inverse of 2 square root of 3 over 3. So the first thing we're going to do with that one, 2 square root of 3 over 3, that's just 2 square root of 3 over square root of 3 times square root of 3, where those two cancel out. So you have 2 over square root of 3. So you have secant inverse